This is part 2 of the notes videos you guys have to cover. So we had already done the entire front page with transformations AH and K. We just have a little bit more to go. So you'll see some notes already have filled in. If at any point you need to pause me so you can just write down what's on the paper already, you can do that. If not, I'm going to keep going. So our focus this unit is quadratics. That's the big universal topic we're talking about. Now, with quadratics, there is multiple ways we can represent a quadratic. So they are all quadratics. We're just kind of changing the makeup and the appearance of what we're looking at. So a very common form is standard form y equals ax squared plus bx plus c. But we're not going to start there. Instead, we're going to start with something called vertex form. The reason we're going to start with vertex form is it's going to have something in it that is very familiar to us. There is A, there is H, and there is K. So when we're going to jump into quadratics, we're going to start with vertex form because our familiarity with A, H, and K. So all of those transformations, okay? So this is going to be our focus now, vertex form. We will come back to standard form. So I write it down so you're like, hey, there it is. But we're going to put that to the side, the whole standard form to the side. We'll come back to it. So we got 3 examples, a little bit more notes on the next page, and that will be the end of this video and the end of all of our notes today. So given the equation of a quadratic in vertex form, so this is in vertex form, describe the transformations of the function, then graph it, okay? So the reason why we started our video notes with transformations is we're gonna still describe transformations and then use that information to graph it. So starting with our transformations, I'm looking at f of x equals negative parentheses x plus 2 squared. So the first thing I see is I see that negative out front. So again, I'm thinking about if it's something in the front, is that A, is that H, or is that K? Is that A, is it H, or is it K? So you get recycling? Yeah, go ahead, grab it. So the in front, that is A. That is A. So if we're thinking about A, we got to think about what is A going to do. So we know A could be a vertical stretch, a vertical shrink, or a reflection. Now, if we look at A in our little cheat sheet on the back, if it's a negative, that's going to flip it, reflect it over the x-axis. So since I see that number out, or that negative sign out front, I know we're going to reflect over the x-axis. That explains this front little negative piece. The second number I need to explain what's happening is that 2 right there. So I think, is that 2? First off, where's it located? And I say it's located inside of parentheses. So if we're located inside of parentheses, we're thinking, is it A, is it H, or it's K? Because we're inside of parentheses, that is H. That is H. And from what I remember about H is it could slide us left and right, but it works in opposites. So if I see a positive 2, we're actually going to work opposite of that and go towards negative 2. So we are going to slide left by 2. The only other piece there is that tiny exponent of 2, but that's just what makes this a quadratic. Okay, so what I want to do is I want to take this information to help draw my graph. Okay, now in blue, this blue, what I'm about to write in blue, this is not our answer. The original parent function is a quadratic that looks like this. Okay, that's the original function in blue. What I'm going to do is I'm going to move things around based on these transformations and write my actual new graph, this equation. I'm going to write it in red by following these transformations. Now, when I'm doing transformations, I kind of do it in a 2-step process. The first thing I work with is the slides, And then second, I'll do any stretch or reflecting. That's kind of the order in which I do these. So where I start is I start with our vertex. That's this tip point right here. I start with our vertex. My slide says slide left by 2. So right now I'm starting at 0, 0, but I need to do my slides first. So slide left by 2. So left, 1, 2. This is currently my new location of my graph. But I also need to reflect over the x-axis. So instead of going up, this graph should be coming down. So right here in red, that is this equation graphed. I slid it to the left too, and I reflected or flipped it over the x-axis. So right here in red, that is my answer. Let's do one more. You could pause me if you want. If you're like, yeah, I think I could figure this out on my own, pause me and work ahead if you want. If you're like, no, I'll just stick with you, keep on playing. So we have h of x equals 2 parentheses x minus 1 squared minus 3. So I got to figure out all my transformations. I start with that front number. I'm thinking about where's it located? It's located in the front, so that must be an A. And from our earlier notes, we knew numbers out front. If it's a number bigger than 1, that is a vertical stretch by 2. That is a vertical stretch by 2. The next thing I need to explain is I see this minus 1 here. It is located inside of parentheses, and when you're inside of parentheses, that is an H. That is an H. So I got to think about, all right, H slides left and right. It works in opposites. So if I see a minus 1, let's head towards the positives. Let's head to the right. We're going to slide right by 1. Slide right by 1. Final number there I need to explain, because I don't need to explain that exponent of 2, is this minus 3 in the back. Because we're in the back, I'm thinking about K. K is located in the back. So A, H, and K. A in the front, H on the inside, K in the back. So K in the back, I see a minus 3. So we need to think about what does a minus 3 do. So K slides us up and down. I'm going to slide down by 3. Slide down by 3. Okay, so I got my vertical stretch. Slide right, slide down. Great. So I know my original graph is going to start at 0, 0. My original graph is at 0, 0, 0, 0. I'm going to do my slides first. I need to go right 1, so I go right 1. And then I need to slide down 3, so I go down 1, 2, 3. And I'm going to put a point. There's where my vertex is at. And what I need to do is I need to do a vertical stretch by 2. And what we remember is it's going to take your parabola, just stretch it up a little bit more. So just a stretched parabola, a little bit taller and skinnier. That is my graph. Okay. Final one, I would really hope after 2 examples, maybe you're feeling a little bit brave, maybe pause me, see if you could write down the transformations, and then see if you could come up with the graph on your own. So pause me, try transformations, try your graph, and then when you're done, unpause me. So if you're going to do this one, the first thing I look at is the number on the inside. I see a minus 1. That is located inside the parentheses. That is H. That is H. I see a minus 1. You got to think about, does that slide you right or does that slide you left? Since I see a minus 1, that is a negative, but we work in opposites. I'm going to head in the positives. We're going to slide right by 1. Other number I see there is that 2. Since it's in the back, that is K. So K slides you up and down because it's positive 2. That is going to slide up by 2. So again, I'm going to try and figure out this graph. It starts at 0, 0, starts at the center. I need to slide right by 1, and then slide up by 2. Up 2. There we go. And that, draw a rough sketch of my quadratic. There you go. So before we move on from this page, the question always becomes, all right, if it is called vertex form, believe it or not, math makes a lot of sense behind why we name things. There is a reason this is called vertex form. So what I want to do is I want to point out what is the vertex of all three of these problems, and let's see if we can make some connections. So the vertex is this tip point right here. It's that little kind of where your parabola, your two arms of your parabola kind of meet. That point is your vertex. So the coordinates here is -2, 0. So the x is -2, the y is 0. The vertex here is over 1, so +1, and down 3. So this one's at 1, -3. And the last one, the vertex is at, my face is kind of blocking it. That is at over 1 up 2. So I'm writing 1, 2 there. Let's see if we can zoom it out. There we go. 1, 2. So believe it or not, we name these vertex form for a reason. And what I would like for you to try and do is figure out, why would they call this vertex form? So look at your equations over here and look at our vertexes over here. And why might they call this vertex form if that's the vertex? So see, if this is the vertex, why would they be calling this vertex form? If our vertex here is 1, 2, why do they call this vertex form? I want you to think about that for a little bit, because if you could figure it out, it makes the next page a lot easier. So if you look, our vertex is at 1, -3. If you look at my equation, I see a 1 right here and a -3 there. On my bottom problem, my vertex is 1, 2. I see a 1 here and a 2 there. The only difference is, see how here it looks like a -1, -3, and over here it's a +1, -3. Over here it looks like a -1, +2. Over down here is a +1, +2. It makes sense, because remember how we think about H? It's inside the parentheses, and it works in opposites. So see how we see a -1 and see a -3, but it becomes +1, -3. That first number is opposites. Same down here. It's -1 over here, +1 over there. Opposites, and then keep the k the same. So the reason we call it vertex form is it is extremely easy to look at the equation and figure out your vertex. Oh. One last bit of notes for you is this last page. I'm not even going to explain it on video. I'm going to wait to explain this in class. But what I need you to do is I need you to have this all copied down. Okay? I want you to pause me, copy down the rest of these notes, because this is where I'm going to start next class period, which will be Thursday. So make sure you pause me, copy all that down, and if you've done that, you've done everything you need to do for Algebra 2 today. All right, great. Thanks. See you Thursday.